The educational materials presented here were developed by students and faculty of the Department of Food Science and Human Nutrition at Iowa State University. Funding for this project was provided by grants from the American Cancer Society Midwest and the Lance Armstrong Foundation. The materials are intended for educational use and are not meant to provide medical advice. We welcome your feedback about these materials. Please use the evaluation survey link on the homepage to provide your comments and suggestions.
This presentation will cover information about vitamin D and calcium and the role these nutrients play in cancer prevention. Vitamin D is a fat-soluble vitamin. This means that it can only be absorbed with fat. Vitamin D is not found in many foods. In fact, it can be difficult to obtain required amounts of vitamin D from foods. Foods that naturally contain significant amounts of vitamin D are fatty fish and eggs. To increase intake of vitamin D, foods have been fortified. Milk is the most commonly consumed product that is fortified with vitamin D. Juices, breakfast cereals, breads, and yogurt are also fortified with vitamin D. Dietary supplements are also consumed by many individuals to meet the daily requirements of vitamin D. There are many forms of supplements, and I will discuss these later. Cholecalciferol is a form of vitamin D made naturally by the body when the skin is exposed to sunlight. However, most people do not get enough sunlight to satisfy their daily recommended intake through sunlight, especially in the winter. Recommended daily intakes are given in international units, which is abbreviated IU. 1 IU is equal to 40 micrograms. The recommendations are 200 IU from birth to 50 years of age, 400 IUs from 51 to 70 years of age, and 600 IUs for 71 plus years of age. These recommendations meet the minimum requirements, mostly based on bone health. Currently, there is debate within the medical community about the daily recommended intake for vitamin D. The debate is about whether or not the current amounts are adequate for all of the functions vitamin D plays in the body. Current research suggests consuming amounts closer to 1,000 IU may be needed to obtain all the potential benefits of vitamin D. Some examples of vitamin D content in foods are shown here. Fish, including salmon and tuna, are excellent sources. Egg also contains vitamin D. The highest concentration is in the yolk. Other good food sources include 3 ounces of beef liver, which contains 42 IU, and 3 ounces of pork spare ribs, which contain 88 IU. Some foods that are fortified with vitamin D are shown here. An 8-ounce glass of milk will contain 115 IU, and 8 ounces of fortified orange juice contains 100 IU of vitamin D. Cheerios are a good source, as are other fortified breakfast cereals. Yogurt is another dairy product that also provides vitamin D. Turning attention now to calcium. Calcium is an essential mineral which must be consumed in the diet. The daily recommended intakes for calcium are highest during the peak ages of bone growth between 9 and 18 years of age. The recommended intakes remain fairly high throughout the rest of life, 1,000 milligrams for 19 to 50 years of age, and then 1,200 milligrams for 51 years or older. Calcium-rich foods include dairy products such as milk, yogurt, and cheese, and dark green vegetables. The calcium found in dairy foods is very well absorbed, whereas calcium in vegetables is poorly absorbed. Obtaining adequate dietary calcium may be a challenge for persons who do not regularly consume dairy foods, and there is substantial evidence that calcium intake is inadequate for many people. For this reason, many foods today have been fortified with calcium. Cereals, breads, orange juice, and other foods can be found with added calcium. Milk and dairy are the richest sources of calcium. A glass of milk provides 300 milligrams and a container of yogurt 230 milligrams of calcium. Spinach and fortified cereals also contribute to calcium intakes. Because vitamin D and calcium are important nutrients and they can be challenging to obtain from foods, there are many different forms of dietary supplements on the market. If you choose to use a supplement, it is important to understand the different types. Both vitamin D and calcium are available in different forms and a wide range of amounts. Many supplements contain both calcium and vitamin D, because vitamin D assists in the absorption of calcium. The two main forms of calcium in supplements are carbonate and citrate. Calcium carbonate is more commonly available and inexpensive. Both forms are absorbed well by the body, but individuals with low levels of stomach acid may absorb citrate better. Carbonate is also absorbed better when taken with food, but citrate is unaffected by the presence of food. The percentage of calcium absorbed depends on the amount of calcium consumed. As the amount increases, the percent absorption decreases. It is recommended that rather than taking one 1,000 milligram supplement, take two 500 milligram supplements several hours apart. Some individuals who take calcium supplements may experience gas, bloating, or constipation, but these symptoms can often be reduced by spreading out the calcium dose throughout the day, taking the supplement with meals, or changing the brand of supplement used. There are two forms available for vitamin D supplements: D2, ergocalciferol, and D3, cholecalciferol. Vitamin D2 is made by the conversion of a sterol found in plants and yeast. Vitamin D3 is the form that is produced naturally in human skin, exposed to ultraviolet B light, and occurs in some animal products, such as cod liver oil, and in smaller amounts in other fatty fish, such as sardines and tuna. Vitamin D3 is the most common form used in dietary supplements and fortified foods, such as milk. Unlike calcium, these two forms are not equal in absorption. Vitamin D3 is metabolized differently than D2, and research shows it is more effective in raising serum concentrations of the active form of vitamin D, and is also able to maintain higher levels for longer. More research is needed in this area, but many companies are switching from D2 to D3 to gain greater benefits from their supplements. Let's take a minute to understand how to calculate the amount of vitamin D and calcium provided in a food from the nutrition label. 1 serving of Cheerios is equal to 1 cup of cereal. The nutrition label includes data for cereal alone and for the cereal with half a cup of skim milk, because it is typically consumed with milk. So be sure to understand which column you are reading. 1 serving of cereal alone has 100 calories. The cereal provides 10% of our daily value of calcium. In order to determine how many milligrams of calcium that provides, you need to know that the daily value for calcium is 1,000 milligrams. Once you have that information, you can calculate how many milligrams in the serving by multiplying 1,000 milligrams by 0.10, or 10%. The result is 100 milligrams of calcium per serving of Cheerios. Similarly, a serving of Cheerios provides 10% of your daily value of vitamin D. The daily value for vitamin D is 400 IU. To calculate the amount in a serving, multiply 400 by 0.10. The result is 40 IU of vitamin D per serving. To find a full list of daily values for all nutrients, you can go to the FDA website shown on the slide and search for daily values. Vitamin D plays important roles in many processes throughout the body. Probably the most well-understood function that vitamin D has is in the absorption of calcium from the small intestine. When vitamin D is inadequate, calcium from the diet is poorly absorbed. Another well-characterized and important role of vitamin D is to maintain appropriate levels of calcium and phosphate in the blood to ensure proper bone formation, mineralization, growth, and repair. Vitamin D has other roles that have been less well characterized. It is thought to improve muscle strength and immune function and reduce inflammation. People at risk for vitamin D deficiency include breastfed infants, older adults, people with limited sun exposure, people with dark skin, and people with fat malabsorption. People aged 50 and older are at increased risk of developing vitamin D deficiency because as they age, the skin loses its ability to synthesize vitamin D as efficiently, and the kidneys also convert less to its active form. People living in the northern latitudes, homebound individuals, and women who wear long robes and head coverings for religious reasons may not obtain adequate levels of vitamin D from sunlight. People with darker skin have more pigment melanin, which reduces the skin's ability to produce vitamin D after sun exposure. Prolonged inadequate intake of vitamin D will lead to impaired bone metabolism. In children, undermineralization of bone causes soft and deformed bones and can lead to the condition known as rickets. Rickets is rare in the U.S. today, but was fairly common as recently as 100 years ago. When children developed rickets, their legs were too weak to hold their weight, resulting in bowed legs, which often persisted into adulthood. Osteomalacia is the adult form of rickets and leads to impaired mobility and bone fractures. And osteoporosis is a condition that leads to weak and porous bones. Calcium is the most abundant mineral in the body. There are two major roles for calcium. By far, the majority of calcium found in the body is stored in the bones and teeth, providing structural support. However, there is a very small and tightly controlled amount of calcium that circulates in the blood. This calcium is required for muscles to contract, blood vessels to expand and contract, secretion of hormones and enzymes, and transmission of impulses throughout the nervous system. All these functions are supported with less than 1% of the total body calcium. A wide range of people may be at risk for calcium deficiency. Children and youth require adequate amounts of calcium to ensure proper bone development. Consumption of dairy products, particularly milk, during these developmental years is of great importance. As adults, bone mineral loss begins to exceed accumulation in the natural aging process. Postmenopausal women and the elderly can become at risk of calcium deficiency associated with bone loss. People with poor diets, particularly lacking in dairy foods due to lactose intolerance or vegetarianism, may also be at risk for calcium deficiency. If dairy foods are not tolerated, calcium supplements should be considered at any age. There is recent evidence that adequate levels of vitamin D in the diet may play a role in the prevention of certain cancers. Thus far, the best studied role for vitamin D has been found in cancers of the colon and breast. In general, vitamin D plays a role in maintaining healthy cells, and when vitamin D levels are low, these protective effects may be compromised. Early studies that correlated cancer incidence with sun exposure rates in populations began the search for a role of vitamin D in cancer. This map illustrates the colon cancer mortality rates in men throughout the United States. Areas shown in red have the highest colon cancer mortalities, while those in blue have the lowest. It is fairly clear that states in the north and eastern parts of the U.S., those with the longest winters, have the higher colon cancer mortality rates. Vitamin D may have a role in cancer prevention. The graph above came from an epidemiological study and shows geographic correlation. An inverse relationship was found between sunlight exposure levels and the rates of incidence and death for certain cancers. Individuals living in northern latitudes were found to have higher rates of incidence and death for these cancers than those living in the southern latitudes. The researchers hypothesized that this is because UVB rays from sunlight are necessary to synthesize vitamin D. This map illustrates the mortality of white females due to breast cancer from 1970 to 1994. As shown here, there is a correlation between the northern, northeastern, and some western states and increased rates of breast cancer. Again, areas shown in red have the highest breast cancer mortalities, while those in blue have the lowest. Most of the southern states are bright blue, suggesting much lower incidence of breast cancer. The graph above came from the same epidemiological study as shown on the previous slide, and again shows the geographic correlation. An inverse relationship was found between sunlight exposure levels and the rates of incidence and death for certain cancers. The exact role of vitamin D in cancer prevention is still unclear. However, researchers know that vitamin D plays an integral role in cellular differentiation. Increased levels of vitamin D decrease the growth of cancer cells and stimulate cell death. Most vitamin D cancer research that has been done is observational, and more epidemiological studies are needed to support the findings that have been made. Observational studies include things like food frequency questionnaires, interviews, and recording dietary intakes, which are all subject to a large amount of misinformation and error. Epidemiological studies are aimed, where possible, at revealing unbiased relationships between exposures such as biological agents, stress, or chemicals to mortality or morbidity. In this case, epidemiological studies would be searching for the link between vitamin D and cancer mortality and/or morbidity. The identification of causal relationships between these exposures and outcomes is an important aspect of epidemiology. Let's take a look at some of the research that has been done. The third National Health and Nutrition Examination Survey, published in 2007 by the Journal of the National Cancer Institute, is one of very few epidemiological studies on vitamin D and colon cancer. The researchers looked at 16,818 participants and examined blood levels of vitamin D. Individuals with blood levels of 80 nanomoles per liter or higher of vitamin D reduced their risk of colon cancer by 72% compared to individuals with blood levels below 50 nanomoles per liter. The American Cancer Society's Cancer Prevention Study 2 Nutrition Cohort, published in 2003 by the Cancer Causes Control, showed a slightly lower risk of colorectal cancer in men, but the women in the study did not show this same effect. This group of researchers studied a group of 120,000 men and women and analyzed their diet, medical history, and lifestyle. The study found that men with intakes of 520 IU or higher of vitamin D through their combined diet and supplementation had a slightly lower risk of colon cancer. In the same study of the American Cancer Society on Cancer Prevention Study 2 Nutrition Cohort, researchers also singled out postmenopausal women who had no family history of breast cancer. These 68,567 women were then given a questionnaire on dietary intake, medical history, and supplement use. Researchers looked specifically at calcium, vitamin D, and dairy consumption in their diets. The study concluded that women who consumed higher amounts of calcium and vitamin D from dairy sources decreased their risk of breast cancer. Take a moment to answer this question. True or false? Vitamin D is not necessary for calcium to be absorbed in the body. The answer is false. Vitamin D is necessary for calcium to be absorbed by the body, as it aids in absorption of calcium from the small intestine, and it also helps maintain blood calcium levels. In research studies, calcium has been shown to play a preventative role in colon cancer and breast cancer, especially breast cancer in premenopausal women. The exact mechanism by which calcium prevents cancer is unclear. At the biochemical level, it is clear that calcium binds to both bile and fatty acids in the gastrointestinal tract to form insoluble complexes. Because the calcium is bound to the acids, it reduces the ability of the acids to damage cells located in the lining of the colon. Calcium also acts directly in reducing cell proliferation in the lining of the colon. Both mechanisms are thought to contribute to calcium's prevention of cancer. A strong relationship between calcium intake and colorectal cancer risk was found in the participants of the Nurses' Health Study and Health Professionals Follow-Up Study, published by the Journal of the National Cancer Institute in 2002. In this study, researchers analyzed 135,000 men and women and found that people who consumed 700 milligrams of calcium per day reduced their risk of colorectal cancer by 35 to 45% when compared to people with intakes of 500 milligrams of calcium per day or less. This effect was only recognized in the distal area of the colon, and intakes showed no effect on the proximal colon. Another study done by the National Institutes of Health American Association of Retired Persons Diet and Health Study, which was published in 2009 by Archives of Internal Medicine, showed that high intakes of total calcium, dietary calcium, and calcium supplements were associated with 20% lower risk of colorectal cancer among men and 30% lower risk among women. A study published in 1998 by Cancer Epidemiology, Biomarkers and Prevention examined women living in Iowa. This study compared 34,000 women divided into two groups. One group consumed approximately 1,280 milligrams of calcium or more a day, and was compared to a second group of women with calcium intakes of 800 milligrams per day or less. Total intakes in the two groups were from both diet and supplements. The group of women who consumed the higher intake of calcium were associated with a 41% reduction in colon cancer risk, while the group of women which consumed calcium intakes of 800 milligrams or less per day showed no reduction in colon cancer risk. The Nurses' Health Study, published in 2002 by the Journal of the National Cancer Institute, included 3,000 women and concluded higher calcium intakes of more than 800 milligrams per day reduced the risk of breast cancer in premenopausal women. The study compared two groups of women where one group consumed a higher amount of calcium of 800 milligrams per day or more, and the second group of women consumed a lower amount of calcium of 200 milligrams a day or less. The group of women with the higher calcium intakes consumed calcium specifically from dairy products, and in particular low-fat or non-fat milk, yogurt, and cheese. The researchers concluded that increased calcium intake of 800 milligrams per day from dairy sources reduced the risk of breast cancer in premenopausal women, but not in postmenopausal women. Another analysis that involved more than 30,000 women was the Women's Health Study, which was published in 2007 by Archives of Internal Medicine. This study again compared two groups of women. One group contained women who consumed 1,366 milligrams of calcium or more per day, and the second group consumed 617 milligrams of calcium or less per day. Results of the study found a reduced risk of breast cancer was associated with the group of women with the higher calcium intake when compared to the group with the lower intakes. The study also only saw the reduced risk of breast cancer in premenopausal women. Throughout this presentation, you have learned how vitamin D and calcium both play roles in cancer prevention. The recommended intake for calcium is 1,000 milligrams per day, which, based on research, this amount is enough to reduce the risk of colon cancer and breast cancer in premenopausal women. The recommended intake for vitamin D is 400 IU. However, this value is under debate. As research shows, much higher levels of vitamin D are necessary to achieve the cancer prevention benefits. There are many ways to incorporate both calcium and vitamin D into your diet. Vitamin D can be consumed naturally in fatty fish such as tuna and salmon, and in eggs. Many cereals and milk products are also good sources of vitamin D due to fortification. Calcium-rich foods include milk, yogurt, and cheese, but remember to choose low-fat varieties of each of these products. Dark green leafy vegetables such as broccoli, spinach, and kale are also rich in calcium. Many foods on the market today are also fortified with both calcium and vitamin D, such as fruit juices and most breakfast cereals. By modifying your diet to include more foods that contain vitamin D and calcium, you may also be reducing your risk for certain cancers, as shown during this presentation. If reaching the recommended intakes of both vitamin D and calcium through foods alone is not possible, your daily requirements can be obtained with the use of dietary supplements.